Let's start with alkanes, which there is no double bond between the carbon and carbon. To know more about how to find the Lewis structure of these compounds and the whisper and the 3D structure of them, I want you to go back to my Lewis structure video and whisper or 3D structure video. The important thing I want to tell you is that the alkanes have the very important formula, which is CnH2n plus 2. And find the formula of the alkanes. For example, if you have the one, for example, in CH4, you have one for C, and you put C for 1 as a C1 here, and you put 1 also because it's 1, we said the N is a number of carbons, you can find that this is the formula of the alkane, which is CH4. I wanted to do for C2H6. What do you think? Do you think the C2H6 is alkane or no? There are different presentation for the alkanes, or we can say all of the hydrocarbons. One is expanded formula, which we show like just the Lewis structure that you were drawing before. Just the Lewis structure, you show all the bonds and the hydrogens and each element in it. So we call it expanded formula. Another one which shows the 3D structure is ball and stick model. There is another one is line angle formula. In line angle formula, if you pay attention to this structure here, you see each angle is a carbon here. And also the end of the lines shows a carbon, one carbon. So here I have a carbon, here I have a carbon, here I have a carbon. I don't show hydrogens in the structure. In condensed structure, we kind of look at what we have in expanded or a line angle and see how many hydrogens attached to each carbon and write it next to the carbon. So you can see that if I go back and look at this bond angle, you see that this is CH3. Also, you can look at this bond and a stick model here. So that's the CH3, that's the CH2, and that's the CH3 structure. You can just put them next to each other. Around each carbon, there is 4 bonds, and one is going to be carbon-carbon if there is a carbon next to it, and the other 3 here, you can see that's the carbon-hydrogen bonds. What about this one? This carbon attached to another carbon, that's the 1 bond, and there are 3 hydrogen attached to it. We're gonna talk about the IUPAC naming. IUPAC is the union that is basically a stand for International Union of Pure and Applied Chemistry. They have put some rules for naming the organic compounds. In the alkanes, the important thing is that we should find the longest chain of carbon when we name alkanes. This rule, finding the longest chain of carbon, it goes for all of the organic compounds. When we reach and to talk about alkenes, alkynes, even other organic compounds that have functional group, we should always find the longest chain. So if you understand the concept of finding the longest chain here, it's going to help you for other uh, uh, namings. So we should find the longest chain of carbon. I will talk about it. And for alkanes, we always should end with ane. So the suffix is ane. So you can see alkane. Alkane, C is ane, ends with ane. So we should always write it down when we want to name alkanes, which, if as we know, all the alkanes have a single bond of carbon-carbon. What is a prefix? Always we should, as I said, we should find the longest chain of carbons, and if we have one carbon in the chain, we call it met. So imagine if I have one carbon and we have alkane, it's going to be methane. If I have two carbon in the chain, it's going to be eth, and it's end with ane. It's going to be ethane. And as so on, is going to be propane if it's 3 carbon in the chain. If it's 4 carbon, it's going to be butane, 5 carbon pentane, 6 carbon hexane, 7 carbon heptane, 8 carbon octane, 9 carbon nonane, and 10 carbon decane, and so on. For example, if we have here the line angle formula of this compound, and here is this expanded formula, just the regular Lewis structure of it, you see that we should just see how many carbon we have. 1, 2, 3, 4, 5. Here it does not matter if we count from left or right. So I have 5 carbon. If we go back to the table, 5 carbon is 5. It's gonna be pent. So we know that for alkanes, which is single bond, carbon-carbon, we end with ane. It's gonna be pentane. What are alkyl groups? Whenever, guys, we have a branch that there is a carbon in the branch, we call it alkyl group. How? So look at this compound. You see that we have 1, 2, 3. That's what kind of formula is? Line angle formula, right? With no hydrogen attached to it. It's just carbons. So I'm gonna start numbering to find the longest chain. That's my longest chain, 1, 2, 3. So that would be the branch out of it. So we call these branches that are made of carbon, we call them alkyl groups. Why? Because if you look at this is CH3, this branch is CH3. So it's just one carbon different from its alkane, which is CH4, right? CH4 is an alkane. If I remove one hydrogen from it, because I attach it to another carbon, it's going to be CH3. So this is called methyl group. I remove the ane from the methane and I add YL to it. It's going to be methyl. So you can see that alkyl group always end with YL, right? So it's going to be methyl for CH3. For 2 carbon, imagine, is like ethane, but I remove the ane and I add YL to it. You can here pay attention that one hydrogen is removed from this two carbon because it attaches to uh, another carbon. Here we have three carbon, it's going to be propyl. When it from the second carbon attached to another carbon, we call it isopropyl. Here we have four carbon, it's going to be butyl. When it's attaching from the one of the carbons is a primary carbon, it can be isobutyl. When it's attached from the second carbon, it's going to be sec-butyl, and is when attached from the tertiary carbon, which is the carbon that has no hydrogen in it, we call it tertiary butyl or third butyl. Okay, guys, let's see if we can name this compound. This is all single bonds, so it ends with A and E. Now we should find the longest chain of carbon. So we should throw all of the possibilities, guys. See what are the possibilities by thinking that we need to find the longest chain of carbon, right? So I go from the left to right is 1, 2, 3, right? They already here numbered it for us. 1, 2, 3. So then I find the longest chain. That's the longest chain of carbon. I will tell you later in a bit that even though we can name it from the number it from here 1, 2, 3, still we're gonna have the same name. 1, 2, 3 still is gonna be the same name. So let's focus on numbering from the left 1, 2, 3. Then I have three carbon is prop. It ends with A and E, propane. Then I know on the carbon 2 I have a methyl group, right? Alkyl methyl group. So it's gonna be on carbon 2. I emphasize on it. Carbon 2, there is on carbon 2, there is a methyl group. So you should emphasize on the carbon that there is a basically a branch out of it or substituent out of it. So it's gonna be 2-methyl propane. If when you find the longest chain, always put it in the box, then you know what branches come out of it. Then I basically, if you are visual, you can obviously see this is a branch out of this longest chain. As I said, there is other longest chains here. So instead of just go from 1 to 3, I can go from 1 to 3. Still it is the longest chain, right? And on carbon 2, again I have methyl group, right? See 1, 2, 3. On carbon 2, I have a methyl group. What about if I go from here? 1, 2, 3. Again, in carbon 2, I have a methyl group. What about if I go from here? 1, 2, 3. Again, on carbon 2, I have a methyl group. So as long as, guys, you get the same name, your numbering is correct. Again, as long as you have the same name, you get the same name, your naming is correct. Okay, let's do this one, guys. Here we have one substituent, and there is a longest chain here, right? Okay, guys, Let's do another example. I want you to find the longest chain. So for sure, we have 5 carbon here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now it's important to see, as I said, we should reach the branch sooner, right? We should reach the branch sooner. So I can start numbering from the right side, then the carbon that has a branch on it is 2, right? Is getting number 2. But if I go from the left side, 1, 2, 3, 4, the carbon that has a branch gets number 4. So this numbering is gonna cancel out because is not getting the carbon does not getting the lower number. Even if I do 1, 2, 3, 4, and 5, again, this carbon is not getting the lower number. So yes, the correct is we go from the right, start numbering 1, 2, 3, 4, 5, because I reach the carbon that has a branch on it and it's gonna get the lower number. So we have 5 carbon pent, right? A and E because it's alkane, and in carbon 2, I have a methyl group. Pay attention, guys. Not always our longest chain is straight, as I said before. So pay attention, it's just by accident kind of that we have the longest chain straight. So pay attention to this. So as I said, you can always put a box around the longest chain to make sure what's the branch. Let's do this one, guys. Okay, we have now 2 branches, right? We have 2 branches. Now what should I do? I should again start numbering from the side that I reach the branch sooner. Of course, after I find the longest chain. Here I have 6 carbon because I do all of the possibilities. You can do it yourself. See what's the possible longest chain. Then you see that if I start numbering from the right, I reach the substituent sooner. Substituent would be number 2, carbon number 2. But if I start numbering from the left, 1, 2, 3, my substituent is going to be under carbon 3, right? So 2 is lower or 3? 2, right? So I should start from the right to reach the substituent sooner. So I have 6 carbon here. It would be hex is alkane, so it's going to be A and E, and with A and E is hexane. So I have on carbon 2 a methyl group. I have in carbon 4 a methyl group. I just say, okay, I have 2, 4. To make it abbreviated, I just say, okay, 2, 4 dimethyl. Di means 2. So it says I have on carbon 2, on carbon 4, 2 methyl groups. So it's going to be 2, 4 dimethyl hexane. So whenever you have the same alkyl groups, you can abbreviate them. Just put the location and put how many of them you have. Hexane. Okay, so why this is not correct, guys? Why 3,5-dimethylhexane is not correct? Tell me. Because is when we do from numbering from the left side. 1, 2, 3, 4, 5, 6. So this is gonna be 3 and 5, right? But this is not correct because we said that we should number from the right side because I should reach the substituent sooner. Again, we can put the longest chain in the box to make sure we visually see the branches. Okay, let's do another one. Here, you can see we have this compound, and you see that if I start numbering from the left, I reach 1, 2, 3, the branch reaches 3. And if I do go from the right, 1, 2, 3. So, wow, both of them, if I number from the right, it's gonna be, this is 3. And if I do from the left, it's gonna be 3. What should I do? So, if you reach the branches both reach the same numbering, you should look at what branches you have. Here I have two different branches. One is ethyl, right? CH2, CH3. And here is a methyl group, right? Two different alkyl groups. If you have two different alkyl groups, you should go based on alphabetical order. Ethyl is lower in alphabetic order or methyl. Ethyl, right? E, right? E, A, B, C, D, E is sooner compared to M, methyl group. So when we're gonna number, we're gonna start numbering from the side that I reach the branch that it has a lower alphabetical order. So I start numbering from the left. Of course, it's gonna be the longest chain, 7. I have 7 here. It's gonna be hept and is alkane, heptane. So it's gonna be 3 on carbon 3. I have a methyl. I have in the carbon 3. I have an ethyl group. It's gonna be 3 ethyl. In carbon 5, I have a methyl group, and it's gonna be heptane. What other longest chain you can find here, guys? Yes, this is also longest chain. See, 1, 2, 3, 4, 5, 6, 7. Even I can do this one. 1, 2, 3, 4, 5, 6, 7. And it's gonna give me the same name. 3 ethyl, 5 methyl heptane. Do it yourself, guys. If I go and do this one, 1, 2, 3, 4, 5, 6, 7, you're gonna get the same name. So if you remember, I said, as long as you get the same name, it's totally fine. And as I said, even not always or a straight line is a longest chain. They just decided to choose this one as the longest chain. But I can choose this one as the longest chain because I get the same numbering. Okay, so here we go with what they chose basically. So even you can put the longest chain in the box, and you see obviously the substituents. Okay, let's do this one, guys. How to name this one? Do it yourself. Pause this video and see if you can do the correct numbering on this compound. Okay, let's do that, guys. Here we have from the left side 1, 2, 3, 4, 5, 6. This is the correct numbering. Why? Because I reach the substituent sooner, right? I reach the substituent sooner. Here is 2 on carbon 2. So, and I have on carbon 2, 2-methyl, and I have carbon 4, and ethyl. So, let's see. What's the name of it? 4-ethyl. When we want to write it down, we go based on the alphabetic order. That's very important, guys. When you want to write them down, you go based on alphabetical order. Okay, always when you write them down, go with alphabetical order. 4 on carbon 4, I have ethyl because E is sooner than M, right? So it's gonna be 4-ethyl 2,2-dimethyl-hexane. This is not correct, right? The bottom one. 2,2-dimethyl 4-ethyl-hexane. Why? Because it's when I start numbering from the right, and we said it's not correct because we don't reach the branch sooner than the left side. Okay, so let's do another one. What's the longest chain here? I helped you here basically. So here the longest chain would be this one. And you can see here that on carbon 1, 2, 3, I have a methyl in carbon. If I go from the right side, 1, 2, 3, 4, 5, 6. If I go from the left, 1, 2, 3, 4, 5, 6. Wow. So here I get the carbons in 3 here. Both of them is 3 if I go from right side, and if I go from left, it's gonna be 3. So which one I should choose, do you think? I cannot go based on alphabetical order because both are methyl. Pay attention, guys. Di, you know, the 2 here, I understand. I say, okay, that's a di here. But the di here does not count in alphabetical order. Okay, so that's not gonna count. Make sure, guys, if you have 2 of the same kind of alkyl groups, here methyl and here is a methyl, you should start from the side that you have more of that alkyl in it, is more crowded. So you should start from the side that you reach the crowded one sooner. This is more crowded than this one, right? Here has 2 methyl group, and here that has 1 methyl group. So I start from the right side. I start from the left side to reach the crowded branch sooner. So whenever you have the same branches and you reach them the same numbering, you are gonna go from the side that you have more branches on it, on that carbon. So it's gonna be what? 3,3,4 trimethyl-hexane. Okay? Again, even you can box here, put a box to make sure what are the branches.